Welcome back to the Framingham Makerspace Persistence of Vision POI build. We are going to turn this right side up for now. Today we're going to, in this episode, we're going to attach the wires to the LED strip. Right now I have 16 LEDs on the strip. We'll cut that down to 15, but I just happen to have the 16 strips. We can cut it down after we attach the wire. As you can see, let me get my little pointer here. So this is an APA 102 strip with 144 LEDs per meter. One of the ways you can tell is it has 4 connections at each end. 5 volts down here, ground at the top, and then it has data and a clock. Have to actually look at which one's which. And then there's 144 of these per meter, so 16 there. So what I have is Superflex silicone insulated super flexible wire. This is 26 gauge. This worked really well for this because it's really jammed in there, so the super flexibility is really nice. The silicone insulation gives it part of the flexibility, plus the silicone insulation does not shrink back at all when you solder it, so you don't have to worry about that. It makes it nice. These strips are non-waterproof, so there's no covering on them, and they have the self-adhesive on the back. You just peel it off and stick them on. I'm going to flip this over. You need to make sure that you get the right end. You'll see that there's an arrow here. This arrow points in the direction that the data travels. So the way these LED chips work is you send data into the first one, it sends the data to the second one. So you can't hook the clock and data up on the other end. It will not travel backwards. So you got to make sure you connect on the end going into with the arrow on the input side of the arrow. So the arrow's facing the data, travels in the arrow direction. 5 volts and ground you could connect on either end, and if you have a really long strip you need to do that just because you have resistance losses, but for this we don't need to worry about it. So what I'm going to do, move that up a little bit. I'm working upside down here just because of the photo stand I'm on, so that's why I've turned the strip so it's upside down. So I'm going to strip just a teeny tiny bit off the end of this wire, like 1/16 of an inch, 1.5 millimeters. And then I'll do the same thing on the black wire. And I'm just going to leave these long right now. I have to figure out how long to make them, and that'll be in the next step when I start putting everything together. So right now I'm just going to leave them as very long pieces of wire so that I can figure that out later. Okay. Now when you strip the wire, you want to make sure that you don't cut off any of the strands inside. So if when you strip it you accidentally cut off some strands, cut the wire and start again so that you have all the strands in there. Okay, and I've got my soldering iron here. Now, the way this fits inside the, we haven't really talked about what this all fits into, but we're putting all this into a preform for a 2-liter bottle. So this is what a 2-liter bottle looks like before they blow mold it. So it's got the threads up here, and then this part is a thick wall. So all this is going to fit inside there. So it's quite squished up. We also have the insert parts that we've 3D printed that go inside to hold all the pieces. So the battery slides down in this one, and then the LED strip kind of goes on top. And then this one holds the microprocessor board and the switch and battery charger, and that goes in like this. And then the whole thing fits inside here, like that. And then the cap that we 3D printed screws on the top, where you can connect it to a string. So, just because of the way everything fits in, I don't I tried originally soldering on the end. So the way these strips work is you can cut them between every LED. And you can see there's these little copper pads here. And you cut right down the middle of those pads. So you end up with half a pad. And it's also on a flexible substrate. These are flex circuits. And then if you just try to solder wire on the end there, inevitably it kind of flexes and something bad happens and it breaks off and doesn't make contact anymore. So what I'm going to do, because all these 5-volt pads are connected all the way down the strip and all the ground pads are connected all the way down the strip, I'm going to go in one LED and solder my red wire to the plus 5-volt one instead of at the end of the strip, one LED in. And I'm going to do the same thing with the ground wire. And then when I put my clock and data lines on, I'm going to do the same thing. I'm actually going to look up which pin on the chip is correct for that. And I would have to go to the first LED on that, but I'm going to solder those wires directly to the pins because that's stronger and it kind of lets it strain relief against the flex a little. So, okay, so first order of business is going to be to pre-tin the end of the wire. Hopefully this time I'm doing a little bit better job of keeping things inside the field of view of the camera as I do this. Whoops. Okay, let's see what we got here. And again, I really like the silicone insulation because it doesn't shrink back at all. Okay, so that's that one. I'll find my black wire here. Hopefully this is still in focus. I can't solder and look at this at the same time. And I don't want to get some extra solder off of there. Whoops. The other thing is you don't have to worry about accidentally hitting the wire with the soldering iron and melting it because the silicone is a high temperature insulation, so it's another bonus. Okay, so now I have my 2 wires tinned, and what I'm going to do is I'm just going to, I already have solder on here. I'm going to turn this around. I already have solder on these pads, but I'm just going to make sure that I get a little bit more on there, that everything's okay. And you have to be careful with this flex that you don't give it too much heat because it kind of melts. I don't know that they use the highest quality flex in the world to make these. I'm just cleaning off my soldering iron tip here. Trying to anyway. Okay, so what I like to do is just get a little bit of solder on the end of the iron, if I can. That's a little bit too much, but I'll try it. Okay, now, again, you want to make sure the arrow is going in the correct direction, and that I'm on the plus 5 volts here. And again, this is probably a little bit too much solder here, but we're going to give it a try. Whoops, I got a little wire hanging out the side. Make sure that doesn't happen. I didn't tin that as well as I thought I did. And again, these you got to be a little careful with because the flex circuit. So, okay, so that I'm tugging a little bit. That seems like it's on there pretty tightly. Use my, got one of these teeny tiny soldering iron sponges, so it's a pain in the neck to try to clean it up. But we'll do what we can. Okay, so now I'm gonna do the ground one, and I'm gonna dress the wire out this side. Let's see if I can. There we go. And I could go up, actually, if I wanted to. I could go up 2 LEDs with this, if that makes more sense for some reason. There's no reason with the power and ground, I don't have to be at the first junction. I could go up to the second junction. There we go. That looks like it's on. And again, I'm just going to leave these long for now. Okay, so that's that. Next episode I'll put the clock and data lines on. I just have to go look up which pins they are. And again, that might be a reason to move up to the second junction to give yourself a little more room in here. Okay, again, this is Framingham Makerspace Persistence of Vision POI, and we'll be right back.